Um, I understand that most of the people in this room are probably developers who don't work in the finance industry. That's okay. I'm primarily a software engineer, not a financial engineer. I'm teaching myself this stuff. So what I'm hoping to do today is provide an introduction to the fundamentals of financial computation from a Python perspective. Why do we use Python for finance? Well, as many of you probably already know, Python has a superb scientific stack, which consists of NumPy, which provides a multi-dimensional array to store either homogeneous or heterogeneous data. SciPy, which has sublibraries and functions that can implement important standard functionality that we often need in either finance or science. Matplotlib, which is good for 2D and 3D visualization, and Pandas, which is built on NumPy and provides richer classes for things like time series or tabular data. And it's tightly integrated with Matplotlib for plotting. An advantage that Python has over something like R is that it allows easy integration into Excel or a production database or a web app. And also R was developed by statisticians, so the learning curve is a lot steeper, whereas Python is often recommended as a first language for beginning programmers. So what can we do with all these tools? Well, something that's very important in finance is time series analysis. And many of you probably don't know what that is. A time series is a sequence of numerical data points in successive order. In investing, it's very common to use a time series to be able to track the price of a security, an option over time. The major tool to deal with financial time series in Python is Pandas. We mostly work with the data frame and the series classes. So I don't know if you guys know, but the main author of Pandas, his name is Wes McKinney, and he actually started developing the Pandas library when he was working as an analyst at a large hedge fund. And also a neat thing is the Matplotlib finance sublibrary has a selection of finance plots. Like the one I have up here is called a candlestick plot. And those are mostly used to view historical stock price data or other time series data. And what's neat is you can easily retrieve, like we did here, the historical stock price data from Yahoo Finance, so that's definitely a good start. We can also work with stochastics with Python. A stochastic event is one that's unpredictable because there's a random variable. In financial markets, we use stochastic models to represent random behavior of things like stocks, commodities, relative currency prices, and interest rates. And these models are then used by analysts to value options of stock prices or bond prices. So random numbers build the basis for stochastic models, and luckily we have the NumPy random sublibrary to generate them for us. We can do simulations of stochastic processes with the purpose of being able to calculate risk measures. And in finance, there's something called a Monte Carlo simulation, which is when you show every possible outcome of a decision to be able to assess the risk. So we're going to do an example. It's going to be very brief, and we're going to use the Black-Scholes model, which is this equation I have here at the top. And that model is for options pricing. It's one of the most important formulas in finance, and it led to a boom in options trading. So if you notice the variables here, you'll notice that Z is a random variable. And we're going to use this to try to simulate future index levels. So when you take this formula down here, we're translating it into a Python and NumPy code, which is fairly straightforward. And then we have the resulting end values for the index level, which are normally distributed in this NumPy histogram. And then here we show the first 10 simulated paths. So taking a dynamic simulations approach like this one, it not only allows us to visualize every single path, but to value options. And Monte-Carlo simulations like this one are really useful in being able to value options when there are a lot of values of uncertainty, like in the Black-Scholes model. Yeah, so that about wraps it up. I mean, it was only 5 minutes. I mean, I think this is a good starting point. I would highly recommend checking out a book called Python for Finance by O'Reilly Media. That's I actually took that example from the book. It's a great way to get started and to go into more detail. I would also recommend checking out a website called Quantopian, and what that does, it allows you to check out these different investment algorithms and even try writing your own on this online IDE. So I have my contact information. I always put it up at the end in case anyone has any questions for me later on. Okay, yeah. I guess that's it.